Let's consider the question on the board. Find dy dx if x equals to 2 minus 3t all over 1 plus t and y equals to 3t minus 2t all over 1 plus t. This is a typical example of a parametric equation, okay? Both equation 1 and equation 2 are connected by a variable known as x and known as t, okay? And we know in our previous class we've learned that the derivative of a parametric equation is this dy over dt multiplied by dt over dx, okay? So in solving this question, the first step is that you have to differentiate the two equations with respect to the variable, okay? You differentiate the two equations with respect to each variable. Now let's start with x. You can see that we have x solution. Please pay attention. Now we have x equals to 2 minus 3t all over 1 plus t. Now, I want you to do something for me now. In differentiating x, which rule are we going to use to differentiate it? Are we going to use, in our previous class we've learned many rules. We have product chain, we have quotient, we have even implicit, we have all this method of differentiation. Which method are we going to use to differentiate this function? The method that we're going to use is quotient rule, you understand? Quotient rule of differential calculus is used to differentiate a function that has a division, you understand? A function that is dividing itself, you understand? A function that has numerator and denominator. In such case, we use quotient rule to differentiate such function. As you can see here, this function x has the numerator and denominator. So let us call the numerator u and the denominator v. This will be u and this will be v. Now, how do we differentiate this? Pay attention. According to quotient rule, the derivative of x is equals to v multiplied by derivative of u minus u multiplied by derivative of v all over v squared. This is the quotient rule of differential calculus. According to quotient rule, derivative of x is equals to v multiplied by derivative of u and u multiplied by derivative of v all over v squared. Now, let us take it step by step. In this case, u is the numerator, that is 2 minus 3t, and v is the denominator, which is 1 plus t. Okay, that is 1 plus t. Now, according to quotient rule, I need to take the derivative of u and v. Du all over dt is equals to, that is, if you differentiate 2, you are going to have 0. Negative 3t, that will be negative 3. And dv all over dt is equals to 1. Okay, so we have differentiate u and v. Now we can now substitute the value into this formula to get the derivative of x. So the derivative of x is equals to v. V is what? 1 plus t multiplied by derivative of u. The derivative of u in this equation is what? Du dt, that is negative 3 multiplied by negative 3 times minus 3. Okay, put it in bracket, minus v minus u. U is what? 2 minus 3t. 2 minus 3t multiplied by the derivative of v. The v is what? 1 multiplied by 1. Okay, put all in bracket. Now all over v squared, that is, I'm going to have all over v squared. V is what? V is 1 plus t, so I'm going to have 1 plus t squared. You can see how I take it step by step. When I start the solution, I'm to differentiate x, but I discover that x is having a numerator and denominator. X is in fraction. So, and from our previous class, we've learned that to differentiate a function that is in form of a fraction, all you have to employ is use quotient rule. And according to quotient rule, we have to use this formula. This is the formula for quotient rule. V du. The meaning of du is that we are differentiating u, which is the numerator, with respect to the variable that is there. The variable that is here is what? T. So we are differentiating u with respect to t. Likewise, we are differentiating v with respect to t. That is why I have du dt and dv dt. Okay. So having done that, I substitute all the formula that I have into this formula. So let us simplify. The derivative of x. Okay. The derivative of x now will be equals to, now, negative 3 times, please pay attention, negative 3 times 1, that is what? Negative 3. Negative 3 times t, that is negative 3t. Negative 3t. Okay? put all of them in bracket, minus 1, okay, minus 2 minus 3t, okay, all over 1 plus t squared, okay. So for this, the derivative of x is equals to negative 3t. Now, if you open this bracket using this negative, you are going to have negative 2 plus 3t, okay. So for this, all over 1 plus t squared. Do you know what I did? This negative that you see here, there is a invisible one. So negative 1 times 2, that is negative 2. Negative 1 times negative 3t, that is plus 3t, okay. So having done that, we can simplify it. Simplify the numerator by connecting like terms. Negative 3, okay, the derivative of x will be equals to negative 3, negative 2, that is negative 5, minus 5, all over 1 plus t squared. Because this negative 3t will cancel this positive 3t. So we are left with what? Negative 3, negative 2. It's like you are owing someone 3 naira and you are still owing that person 2 naira. That means you are owing altogether 5 naira. That's why I have negative 5, okay? So, and this denominator is here. So the derivative of x is what? This is the derivative of x. Now, let us look for the derivative of y. Okay? Let us look for the derivative of y. I'm going to erase what we have on the board so that there will be space for to calculate the derivative of y. So, please pay attention. So, the derivative of x is equals to minus 5 all over 1 plus t squared. Okay? Now let us find the derivative of y. We are still going to make use of the quotient rule because y is also in the quotient form. So y is equals to 3t minus 2t all over 1 plus t. So let us proceed. For this, I'm going to have derivative of y is equals to 1 plus t multiplied by, okay, 3 minus 2t, that is 1. So multiply by 1 minus 3t minus 2t. 3t minus 2t is what? Please pay attention. 3t minus 2t will give us t. You understand? So I'm going to have t multiplied by 1. Okay, all over 1 plus t squared. 1 plus t squared. You see, I just like what we did in the previous when I want to find the derivative of x, it's also the same thing that I did, okay? Are you getting what I'm trying to say? It's simple, okay? It's simple. You know that when I want to find the derivative of x, I make use of quotient rule. I also did the same for y. So it's just I didn't show all the solution. If you want to learn more of quotient rule, you can check the channel and check the playlist, differential calculus. You're going to see many videos that I've already done on quotient rule. There are many soft examples that you can watch to learn more on it. So let us proceed for this. I'm going to have derivative of y is equals to 1 plus t minus t. Okay? All over 1 plus t squared. Okay? Derivative of y is equals to, now please let us open this bracket. I'm going to have 1 plus t minus t all over 1 plus t squared. Okay, so the derivative of y is equals to 1 plus t minus t, that is 1 over 1 plus t squared. Okay, do you understand what I'm saying? So please pay attention. Do you see the derivative of x that you see here can also be written as dx all over dt? You understand? Because we are differentiating x with respect to t. The x dt is minus 5 all over 1 plus t raised to the power of 2. Now, dy all over dt is also the same thing as minus 5 is 1 over 1 plus t raised to the power of 2. Oh, put this bracket, which is what we got here. Do you understand? Okay, you might be wondering how I got these values. You see, I apply quotient rule that we use while we are differentiating the x dt. You understand? So you can see that this is u and this is v. You understand? And according to quotient rule, we are going to have derivative of y is equals to v, which is 1 plus t multiplied by derivative of u. If you differentiate 3t minus 2t, you are going to have 1. So I have 1 here, multiplied by 1 minus, open the bracket, u, 3t minus 2t. 3t minus 2t multiplied by the u, that is 1. So all over v squared. V squared. V is 1 plus t. So v squared is 1 plus t squared. Okay? I'm just showing you this. I'm showing you this so as to help you to understand how I got this derivative. Okay? So here, the derivative of y is equals to 1 plus t minus 3t plus 2t. Okay? All over 1 plus t squared. Okay? See, listen to me. If you multiply 1 times 3t minus 2t, you're going to have 3t minus 2t. And if you open this bracket, you're going to have minus 3t plus 2t, because minus will multiply this negative 2t and it's going to give you positive. Okay, so the derivative of y here will be now 1 plus t. If you collect like terms, t plus 2t will give us what? 3t. So I'm going to have 1 plus 3t minus 2t all over 1 plus t squared. Okay, that is what? 1 over 1 plus t squared. Okay, that is how I got the derivative of y with respect to t as 1 plus t, 1 over 1 plus t squared. Okay, so that is the solution. Now let us find the dy dx. What we did is we differentiate to the two equations. Okay, now having done that, we can now proceed to find dy dx. dy over dx, according to the rule that I gave you in our previous class, dy dx is equals to dy dt. dy dt is what? That is 1 over 1 plus 1 plus t squared. 1 over 1 plus t squared multiplied by dx dt. Okay, multiply dt dx. Don't forget that I told you in our previous class that dt dx is the inverse of dx dt. You understand? When you take the reciprocal of dx dt, you're going to have dt dx. And dx dt is what? Dx dt is 1 minus 5 all over 1 plus t squared. So dt dx will be 1 all over, just like what we have here, 1 over dx dt. That will be 1 all over minus 5 all over 1 plus t squared. Now let us simplify. Please, I want you to pay attention. I want to simplify this aspect now. Okay, I want to simplify it. See, 1 all over minus 5 all over 1 plus t squared can be written as 1 divided by minus 5 all over 1 plus t squared. Okay, now this can be written as 1 multiplied by 1 plus t squared all over minus 5. Okay, so the reason why I show you this is because I want you to understand, so that by the time I replace 1 over minus 5 all over 1 plus t squared as this, I'm going to have, please pay attention, that means that I'm going to have we're going to have 1 plus t squared all over minus 5. That is the final, when I simplify this, I'm going to have 1 plus t squared all over minus 5. So I'm going to replace it. Okay, dy all over dx will now be equals to 1 over 1 plus t squared multiplied by 1 plus t squared all over minus 5. Okay, so now this can eliminate this. So we are going to have dy all over dx is equals to 1 over minus 5. Okay, so and you can put it like this, or minus 1 over 5. That is the derivative of y with respect to x. You can see that it's simple. Okay, it's simple. All you have to do is just to understand the basic concept. And if you missed our previous class, you can check the channel. Okay, click on the playlist on this channel. Those classes I've piled them together. Just watch those videos. Okay, watch it to improve your knowledge, because these are the kind of questions you might come across in your exam. And if you are solving an objective question, they're going to give you a simpler one where you can think. So make sure that you do it very well. Okay, so that will be all for this class. If you have any question, let me know in the comment section. And before you go, don't forget to click on the like button, and don't forget to subscribe, and make sure you share the video to your friends. Okay, that will be all for this class. See you in the next class.